All right, so this is a lesson on the difference between alkanes, alkenes, and alkynes. I will also be looking at the structural formulas of different types of hydrocarbons. So using this information, you should be able to revise for the content. All right, so we're looking at hydrocarbons. We have alkanes, alkenes, and alkynes. Alkanes are single bonds only. So it has a chemical formula of CnH2n plus 2. Examples of alkanes include methane, ethane, propane, butane, pentane, hexane, and heptane. So methane has a chemical formula CH4, ethane will be C2H6, propane will be C3H8, butane C4H10, pentane C5H12, hexane C6H14, heptane C7H16. So you can see that for alkane, all of these examples are part of the same homologous series. What is a homologous series? It means that they have a very similar chemical properties, and there is a trend to its physical properties as well. But what you can also observe is that the number of carbon actually increased by 1. From methane to ethane increased by 1, the number of hydrogen increases by 2. So from ethane to propane, you can see that carbon increased by 1, hydrogen increased by 2. Same goes from propane to butane, butane to pentane, pentane to hexane, hexane to heptane, and so on. So once again, when we talk about alkane, they actually follow the chemical formula of CnH2n plus 2. For example, if we talk about methane, it has a chemical formula of CH4. So number of carbon will be 1, number of hydrogen will be 2 times 1 plus 2, which is 4. If you look at the structure of isomers, and that's something that we will be looking at the example below. Structural isomers are structures that have the same chemical formula as discussed. Chemical formula, once again, chemical formula that it follows is CnH2n plus 2. So the chemical formula has to be the same if they are structural isomers of one another. But they have different structural arrangement. So by looking at these structural formulas of butane and 2-methylpropane, you can see that butane is a very straight structure. It is unbranched as compared to 2-methylpropane. It has a branch on the second carbon, as you can see here. And because of that, there is a difference in terms of the melting point between butane and 2-methylpropane. Butane has a melting point of minus 138 degrees Celsius. 2-methylpropane has a melting point of minus 159.6 degrees Celsius. So the melting point of 2-methylpropane is lower as compared to butane. Why? When we are talking about these structures here, we know that they are hydrocarbons, which is they are non-polar. The intermolecular forces that can only exist in a non-polar molecule is dispersion forces. So butane actually has a larger surface area to molecules on the outside as compared to 2-methylpropane. And there is a reason why butane will have a greater dispersion force as compared to 2-methylpropane, as you can see here. There is a reason, once again, the melting point on butane is greater than 2-methylpropane because it has a greater dispersion forces on butane as compared to 2-methylpropane. So this is the general idea of what an alkane is. We look at alkene, it says alkene consists of a double bond. The chemical formula of alkene is CnH2n. We have many different examples of alkene. We have ethene, propene, butane, pentane, hexane, and heptane. So follow the chemical formula CnH2n. For example, if you look at ethene, it has 2 carbon. The number of hydrogen will be 2 times 2, which is 4. So if you look at structural formulas, we have butane, we have but2-ene. So we talked about structural isomers before, which is the structures that have the same chemical formula but different structural arrangement. So butane, it has the chemical formula C4H8. But2-ene has chemical formula C4H8 as well. For butene, it has a double bond on the first carbon, as you can see in red. And bear in mind, when we talk about first carbon, we talk about towards the closest end. So in this case, butene, the closest end is towards the right. So as circled in red. And but2-ene, it has a double bond on the second carbon. So these are what we call the structural isomers of one another. So what makes alkene different from alkane? Alkene can undergo the addition reaction. We cannot find addition reaction in alkane. Why? Because it consists of single bonds. Alkanes are saturated and alkenes are unsaturated. There's a reason why if the structure of the molecule can undergo the addition reaction, we can say that particular structure is unsaturated, and that particular structure is not an alkane structure. So addition reaction, there are many ways of doing it. One way is to add bromine gases into the alkene structure, and those bromine atoms will now bind towards those carbon that has a double bond. Because carbons, as we know, is in group 14, it has 4 valence electron. It can be bonded to 4 other atoms. So if we look at alkenes, we know that we have those carbon that are double bonded. They are actually bonded to 3 atoms instead of 4. So there's a space around those carbon that enable bromine gases to be added towards the carbon. And that enables us to actually differentiate between an alkane structure, which is saturated, and an unsaturated structure. Let's look at alkyne. Alkyne, it says it consists of a triple bond. The chemical formula of alkyne is CnH2n-2. So we have different examples. We have ethyne, C2H2, propyne, C3H4, butyne, C4H6, pentane, C5H8, hexyne, C6H10, and heptane, which is C7H12. So when we look at this structure here, you can see that it follows the chemical formula, which is CnH2n-2. Because alkyne structures consist of a triple bond. If you look at structural formulas at the bottom here, if you look at but1-ine, or we look at but2-ine, but1-ine has a triple bonds on the first carbon, but2-ine has a triple bond on the second carbon. So if it's a triple bond, you can see those carbons that have a triple bond, they are only bonded to one other atom because 3 of their bonds are towards another carbon. So this is structural isomers of one another. So but1-ine and but2-ine, they are structural isomers of one another. Bear in mind, but1-ine can also be known as butyne. So sometimes when you write, you can write as butyne, you can write as but1-ine. And then the person reading will know that the triple bond is on the first carbon. Let's look at the structural isomers of pentane. So it has a chemical formula of C5H8. Why is it C5H8? It follows the chemical formula. It has 5 carbons, so the number of hydrogen will be 2 times 5 minus 2, which is 8. So we have pen1-ine, we have pen2-ine. We also have 3-methyl but1-ine. So what is 3-methyl but1-ine? You can see that you have 5 carbons in total, but one of the carbon is actually on the third carbon. So when we are doing this drawing of 3-methyl but1-ine, you need to bear in mind, we need to prioritize the triple bond first. So triple bond is on the first carbon. In this case, the citrine, the methyl citrine is on the third carbon. So when you are calculating, you need to calculate based on where is the location of the double and triple bond before you look into the branching. Unlike alkane structure, we know alkane structures do not consist of double or triple bonds. So we only look at the branching. But if you look at alkenes or alkynes, we also need to take into consideration of the double or the triple bond before we look into the branching.